And hello, welcome back again, guys. Today we're gonna discuss about the geometric series. So let's start. So the first is an infinite sequence is a function whose domain is set of positive integers, which is a sub 1, a sub 2, a sub 3, a sub 4, 2, a sub n, which is any number. So the first three terms of the sequence a sub n equals to 2n squared are a sub 1 equals to 2 times 1 squared equals to 2. That's the first term. A sub 2 equals to 2 squared, 2 times 2 squared, which is 8. So a sub 3 is 2 times 3, 6, and 6 squared is 8. 6, no, 3 squared is 9. 9 times 2 is 18. That is the finite sequence. So basically infinite sequence is infinite, and the finite sequence has the last term, which is it is not infinite. So a sequence in geometric, if the ratios the third sequence is geometric. A sequence is geometric if ratios of consecutive terms are the same. So when the ratios are consecutive terms. No, when the ratios are the same. So first is 2, 8, 32, 128, and 512. So to find the ratio of first term, second term, we need to divide second term divide by first term. So 8 divided 2 is 4. Then third term divided by second term, 32 divided 8 equals 4, and so on. So their common ratio is 4. That's geometric sequence if they have the same common ratio. The nth term of a geometric sequence has the form E sub n equals to a sub 1 r to the power of n minus 1. So where r is the common ratio of consecutive terms of the sequence. So for example, this one 15, 75, 375, and 1875. So first we divide second term to first term, which is 15 plus 75 over 15 is equals to 5. So let's try again. 375 divided by 75, it is also 5. So the common ratio is 5. So the formula a sub n equals to a sub 1 r to the n minus 1. So it will be 15 times, which is 15 is a sub 1. So 15 times 5, which is the ratio. So n minus 1. So find the ninth term of geometric sequence 7, 21, 63. So let's find the ninth term. So first is the a sub 1 is 7, and so let's find the common term, the common ratio. So 21 over 7, second term divided by first term is equals to 3, which is the common ratio. So a sub n equals to a sub 1 r to the n minus 1 plus 2. First is the a sub 1 is 7 times the ratio is 3 to the power of n minus 1. So we're gonna find the a sub 9. So it is the ninth term. So a sub 9 is equals to 7 times 3, which is the ratio, n minus 1, which is n is 9, minus 1 is equals to 7 times the quantity of 3 to the 8th power. So 3 to the 8th power is 6561. So 7 times 6561 is equals to 45,927. So that is the ninth term of the sequence. So the sum of the first n terms of a sequence is represented by summation notation. So upper limit of summation is that n, index of summation, and the lower limit of summation. So it is because the n equals to 1 to 5, so that's it. So 4 to the nth power equals to 4 to the first, 4 to the second, 4 to the third, 4 to the fourth, and 4 to the fifth, which is 4 times 1 is 4. 16 times 4 times 4 is 16, and 4 times 4 is 64. So 4 to the fourth power is 256, and 4 to the fifth power is 1024. So overall is 1364. So that's the sum. Sum of a finite geometric sequence is given by the S sub n is equals to summation I equals to 1 to n a sub 1 r I minus 1 r raised to I minus 1 is equals to a sub 1 times the quantity of 1 minus r over r to the n power over 1 minus r. So for example, this is a finite sequence because it has the last term, which is 640. First term is 5, 10, 20, 40, 80, 160, 320, and 640. The term is 8 terms, which is the n. So the a sub 1 is 5, and 1, 2, and the a sub 8 is 640. So let's find the common ratio. Second term divided by first term, or third term divided by second term. So it's for second term divided by first term is equals to 10 over 5 equals to 2. 10 divided 5 is 2. So S sub n is equals to a sub 1 times the quantity of 1 minus r to the nth power over 1 minus r. So S sub n is 5. This is the first term. So 1 times the quantity of 1 minus 2, which is the common ratio to the nth, to the 8th power, which is the n. N is the terms over 1 minus 2. Because this equals to 5 times the quantity of 1 minus 2 to the 8th power is 256 over 1 minus 2 equals to 5 times the quantity of negative 255 over negative 1, which is 1275. That's the sum of this finite sequence. So that's it for today, guys. Thank you, and see you next time, and goodbye.